So let's talk a little bit about San Francisco. We certainly have experienced a lot of similar questions from stakeholders, but I wanted to maybe complement what my colleagues have shared by talking a little bit about similar questions in commercial. So we'll talk about what problems have come up, and a lot of them about perception, how rickety is the grid, how close to reality is this historic image, what resources do we have to improve our understanding, particularly public information, and then what do we learn from that process? And the context for these questions being asked most recently has been our work with local stakeholders in a zero emission buildings task force, laying out San Francisco's goals for addressing our responsibility to climate action and asking them exactly how we could work together to accomplish what needs to be done. And really came to some high-level conclusions that we have a shared interest with property owners and residents of San Francisco that there's a great cost if we fail to act on climate, and there's a shared benefit as well if we do act accordingly. That stakeholder process led to quite a lot of outcomes, which I'm just covering the highlights of here. A commitment to redoubling of our climate action goals to aim for a 60% reduction against compared to 1990 levels by 2030, getting our downtown to zero emissions by 2035, and net zero emissions citywide by 2040. In the context, there's a lot of detail to that, and this is definitely not a comprehensive review of the implications, but one question was, hey, is the timing of those goals is very aggressive. Can the grid actually be prepared? Can we meet the changes in load that are implied by those high-level goals? And so it is. We worked with Lawrence Berkeley Labs and the National Renewable Energy Laboratory on this. And one thing we recognized is that there are good examples of electrifying an individual building, and there's a lot of great resources examining that. Of course, there's a ton of great resources. The utilities have been investing in maintaining, expanding electric grids for more than 100 years in San Francisco. And usually a city, though, is focused on infrastructure in where it's expanding, and also the operation of the local economy and generally public safety. And so when we look at grid infrastructure improvements, while as a city official, I'm not an expert in that subject matter, I don't work directly on it, some things are observable. They take time, they take money, they're complicated. And the local government's role is very clear when we're talking about new development, that we need to ensure that there's adequate infrastructure to serve our community. But the question of what the local government's role is in working with the utility in serving and changing the existing built environment is a little bit newer and a little bit less commonly discussed. And so we recognize one other barrier, and that's that utilities have a lot of expertise, but at the same time, utilities have obligations both to their shareholders as well as to the public in terms of data privacy, and in turn they have data that they view as proprietary, and so that can limit and slow down our understanding of the built environment. And so what we did is take a step back, and we had a long-running project with the National Renewable Energy Laboratory and Lawrence Berkeley Labs, looking at ways to improve insights that could be gleaned from energy usage data while recognizing the privacy implications and privacy constraints that apply to energy usage data. And so just as one component of that larger project, we asked here, how far could we go with what public information, so what the city does know about the built environment, about energy consumption, and about the equipment that is operated in the city, and could we use that to gain some insights about the grid? San Francisco, somewhat uniquely in Northern California, does have data about the code vintage. Well, we all have data about land use and therefore code vintage of properties in our community. We have a little bit more granular data about equipment that any community could collect from permitting data, but we happen to also collect from mandatory energy audits that have been required for a number of years. And then for 12 years, San Francisco's required energy benchmarking and disclosure. And so we have monthly energy consumption data for a large fraction of commercial buildings. And then on the utility side, while the process of planning the details and infrastructure of the grid is again, utilities province, there is some key public information as an indicator that's required to be published. And one element of it is the integration capacity analysis. And the concept there, the use case is really what sort of DERs can be integrated into the grid. Often solar is the first thing people would think of, but it does give an indication of what is the set of major equipment serving a particular area, and what's the remaining capacity of that equipment to address changes in load. And then we also recognize that the biggest driver of investment and improvement in the grid has to be peak demand. The infrastructure has to be sized to serve the greatest load in a given year. So I'm condensing a kind of a long thing, and I'm going to just hit the highlights here. So to quantify the impact of electrifying all the buildings, all commercial buildings in a given district, really boil it down to where are we going to examine. So one of the places we examined was Fisherman's Wharf, gathering those public records about the local built environment and its energy consumption, the ICA data and other data published by PG&E about the grid capacity and infrastructure. And we did the same thing for the design district. It just is a little bit less recognizable if you're not here in San Francisco. But that's a district just east of the 280 freeway. Also composed of commercial buildings, and we focused on districts that were entirely commercial, in part for novelty, in part because we don't have the same level of detail about the energy consumption of residential buildings. And so the process, again, result, this is a long scientific paper, but the bottom line is a construction based on public records of a 10-minute load profile for each building, calibrating that against monthly energy usage, and then looking at a number of different scenarios for how those buildings could be improved over time, aggregating that up to get a 10-minute load profile at the district scale, and comparing that to today's state, that the grid works today, the grid is serving us. And so implicitly, if the load is no greater than before, then we'd have a clear answer, and where the load is within the capacity that's indicated by the public information, we'd also have a pretty high level indication of what's possible. We applied a number of electrification packages. Now, I'll go through these in a lot of detail, but the main point is on-the-shelf technology in terms of both electrification and efficiency improvements, and oh, good, that's visible. And that yielded 4 basic scenarios. So a characterization of today's energy consumption given the local built environment, and again, calibrating that to the reality that we have some information about. Examining what would happen if all those buildings were electrified to code minimum, examining if they just did efficiency improvements, and then looking at the combination of the two. And a lot of the fundamentals are pretty straightforward. One, updating equipment to modern standards, improved efficiency. So it did increase annual electricity consumption, but decreased gross annual total energy consumption if you include gas and electric. And so gas and electric are just on a common scale here for simplifying the visual. And electrification and efficiency work really well together to actually cut annual energy consumption below the baseline level, as well as electricity consumption. Second, more importantly, as we were talking about, the key question in terms of is the grid ready was what's the change in the peak? And we did observe and document changes in the timing of the peak. They're relatively modest, but the main finding was that mixes of uses helped the commercial district, commercial buildings within a district offset the different changes in their annual load profile. And so to summarize that at annual scale, so a 7% increase in load with simple electrification in one district, and actually a decrease in peak demand in another district just for bringing up equipment up to current standards. And in both districts, significant opportunity to reduce peak demand on the grid through investment in efficiency and electrification together. In each case, the results are implicitly within the capacity of today's grid. even where there was the increase. And then, of course, on the assumption that the grid would continue to be able to meet current load, things look very promising for the combination of efficiency and electrification. So a couple lessons from this: we can gain some insights, significant insights, using public data. And the great benefit of using the public data was the full set of results is non-proprietary and public, and so we can have a public discussion about what that means. And that if, looking at the role of efficiency, we see something similar to there are commonly conversations in the residential sector, that investing in efficiency is a great strategy to improve confidence that today's grid can handle electrification, even before we get to more complicated or more of the moment approaches such as load shifting or advanced demand management. There were a lot of caveats, as you might imagine, in the study, which I'm just for time not putting it all through. So I'm just summarizing them with the one asterisk that this does not represent grid planning. We're not confused about that. It really was to answer this main question: is today's grid able to handle electrification at the district scale? And it does look like it can. Thank you.